Hello, Math Wizards! Welcome to a new lesson episode of Just Math PH. For today's math lesson, we will learn about the similarities and differences of linear equations and quadratic equations. These similarities and differences will be based on their equations, their roots or solutions, and their graph. For linear equations, these equations are of degree 1. Degree 1 means that the highest exponent of our unknown variable or ang value ng variable na hinahanap natin must be 1. To understand more about it, let's have the standard linear equation, which is ax plus b is equal to 0, where a and b are real numbers and a is not equal to 0. A and b here are given real numbers. This leaves us x to be our unknown variable. Now we learned that in our previous math lessons that if a variable has no visible exponent, it is understood that its exponent is 1. That is why this equation is of degree 1. Now for an example, 2x plus 3 is equal to 0, where a is equal to 2, b is equal to 3. So this gives us x to be our unknown variable. So guess what is the exponent of x? That is right, it is 1. Therefore, 2x to the power of 1 plus 3 equals 0, or 2x plus 3 equals 0 is an example of linear equation. Now let's move to quadratic equations. If linear equations are equations of degree 1, quadratic equations are of degree 2. It means that the highest exponent of our unknown variable must be 2. To understand more about it, let's have the standard quadratic equation, and that is ax squared plus bx plus c is equal to 0, where a, b, and c are real numbers, and these numbers are again given numbers, and a is not equal to 0. Now notice that we have two x's here, this one and this one. However, the variable x, which has the highest exponent, is this one, and its exponent is 2. The highest exponent is 2. That is why this equation is of degree 2. For an example, 2x squared plus 3x plus 1 is equal to 0, where a is equal to 2, b is equal to 3, and c is equal to 1. So notice that the exponent of our unknown variable, or the highest exponent of our unknown variable, is 2. It means that 2x squared plus 3x plus 1 equals 0 is an example of a quadratic equation. Now let's move to the root or solution of linear equation. Root or roots are value or values that satisfies the equation. It means that this is the value of the unknown variable that makes the left-hand side of our equation equal to the right-hand side. For distinction, linear equation has only one real root. Example, 3x minus 6 equals 0. The unknown variable is x. We need to find the value of x, or the root of 3x minus 6 equals 0. We know that 3x is equal to 3 times x. So the value of x is equal to 2 because 3 times 2 minus 6 equals 0. 3 times 2 is 6, and that is 6 minus 6 equals 0 is true. Therefore, 2 is the root or solution of 3x minus 6 equals 0. So again, the linear equation here, 3x minus 6, has only one real root, and that is 2. How about the roots or solutions of quadratic equation? Quadratic equations may have one or two real roots. For example, x squared plus 5x plus 6 equals 0. We need to find the value of x that will make the left-hand side of our equation equal to the right-hand side, which is 0. So what do you think would be the value or values of x? That is right. X is equal to negative 2. We will substitute negative 2 to the x's here. And that is negative 2 squared plus 5 times negative 2 plus 6 equals 0. Simplifying this, it will be 4 plus negative 10 plus 6 equals 0. 4 plus negative 10 is negative 6, and that is negative 6 plus 6 equals 0. Now there is another value for x, and that is right. X is equal to negative 3 because if we substitute negative 3 to our quadratic equation, it will become negative 3 squared plus 5 times negative 3 plus 6 equals 0. Simplifying this will become 9 plus negative 15 plus 6 equals 0. 9 plus negative 15 is negative 6, and that is negative 6 plus 6 equals 0. Therefore, we have two real roots for this quadratic equation, and that is negative 2 and negative 3. Now, to graph the underlying functions of linear equations and quadratic equation, we will use a sketchpad for us to easily graph them. So let's graph a linear function 3x minus 6, or f of x is equal to 3x minus 6. So this is the graph of the linear function 3x minus 6. Now let's have the graph of the quadratic function g of x is equal to x squared plus 5x plus 6. So here it is. So notice the big difference of the two graphs. Now to summarize the graph of the linear function and the graph of the quadratic function. So this is the graph we had earlier, and this linear function will have a straight line as its graph. That is why it is called linear from the word line. Well, the quadratic function will have parabola as its graph. So again, linear function will have a straight line as its graph, and quadratic function is a parabola. Now to summarize the similarities and differences of linear equations and quadratic equations, we learned that linear equations are equations of degree 1, while quadratic equations are of degree 2. And linear equations will have one real root. Quadratic equation may have one or two real roots. While the underlying graph of their functions, linear functions will have straight line and quadratic functions are parabola. Thanks for watching.